Right, folks, we could, you get back to your seats and we'll move on to the next presentation. So, how's lunch?
Okay,
Okay. So, for me, sorry. Not mine. So with the lunch, you have the promise to say, wait for this happen. All that.
Oh.
Usually I mention that when I give courses, especially if you get lunch like that. So hopefully yourselves online had a good 45-minute break, and you had yourselves a good lunch. So we'll just continue on with our next presenter. So our next presenter is Alexa Marco. Alexa is operation manager at Six Sync Consulting. With her undergraduate environmental degree alongside her project management professional, she is passionate about educating and supporting others to achieve sustainable project and organizational objectives. When she is not managing Six Sync's battery integration projects, she's supporting her students as a college professor. She is passionate about continuous learning and looks forward to presenting on the importance of change management in the new battery technology implementation. So please welcome Alexa.
Hey, so hello everyone. I'm excited to be here today. I'm Alexa, as mentioned. So as we adopt new technology, we have essentially thrown a wrench into the mix of the way we were once doing things, and our day-to-days have now shifted. And I'm excited to be here today to talk about the importance of change management and its emphasis on how battery safety training can help enhance the adoption of electrification. So I am a college professor, and I know that us at home and us here today in person can lose interest and or attention to these presentations. So I have added a little bit of an interactive side of these presentations. So I will ask you now, for those at home, you can go to slido.com and add this code in. For those of you here in person, you can pull out your mobile device and go out to slido.com, scan this QR code, I believe it's scannable, and enter this code. There will be a few question prompts throughout this presentation that we are going to kind of insinuate some conversation around and hopefully bring some attention and or thoughts throughout the presentation. So I'll give you a minute there just to load on. Again, going to slido.com and putting in that code 13895143. Everyone can participate, whether you're at home or here in person.
Answer the first question.
I
think I jumped on there.
Sorry, that's because it's on this slide. Not yet, no. Well, once you're in, we'll give you about 10 more seconds and then we'll be prompting the first question. All right, so hopefully we're all in. Ready, prompted? So, sorry. So first question here to kind of prompt your attention. Well, you may not be able to see this on the screen at home. You will be able to see this on your slido.com, both the question and the results. But the first question we have is, how well do you understand BEVs today? The options there are, I'm actively using machines, I'm considering buying, I drive an EV at home, I'm just interested in the topic. I'd like to
It should be a good one saying all of the above.
all of the above. I believe there's also a multi-select option, or it's just a single option select.
No, you can select them all.
Multiple? Yeah, so there's a multi-select option there. More than one applies to you. Are we ready to see the results? Okay, so interesting insight there. So unfortunately, us in the room here, you cannot see this. It's not integrated through the presentation, but you can see the results on your mobile device on slido.com. So the consensus here was about 80% of us are interested in the topic. An additional 34 are actively using machines, 23 are considering buying, and 4% drive an EV at home. I think we all wish we could drive an EV, but it's not personally financially feasible quite yet for some of us more than others. Thank you for your insight. So today, again, I'm going to talk about the importance of change management in the electrification as we go through this journey day by day. A bit of an introduction about me. My name is Alexa. I am the operations manager here at Six Sync Consulting. We're a small outfit located in Midland, Ontario. Our team is located across the province of Ontario. We do work fully remotely, other than when we are required to be on site. I have 2 years experience in the electrification industry, about 10 years experience in project management specifically, and I have my project management professional. With that, I'm not an engineer, and while a lot of us here are very technically minded, and the majority of us in the room or online may be engineers, me not being an engineer has allowed me to have a unique perception and insight into the current industry and the projects that we work on with our clients. I'm also a college professor. I teach at multiple colleges across the province, and I currently support about 1,000 students in their higher education journey. A bit about Six Sync, we have 4 pillars that we kind of work on our projects with our clients. First is our experiential training and learning services, regulatory risk and requirement and supply chain navigation, research and roadmap development, and lastly is product commercialization. So we have an array of services that we offer our clients within the industry, both on the OEM and end user side, and we have a curated approach kind of for each problem and how to tackle that. So, oh, sorry, I forgot, I didn't move forward. I've got 2 slideshows here moving at the same time, but here's my bio profile, and apologies, so kind of what I just went over there. So next slide we have here, I wanted to start off this presentation and being here today of where the adoption rates and projections currently are in Canadian mines for battery electric vehicles. With this adoption does come many growing pains into this essentially new market, not only on the OEM, but end user side. Adoption has been slow, but there is a lot of opportunity. This does come with some conflict. And essentially, we can all kind of come to the consensus that there are some things holding us back. Now, this S-curve is a representation of the different adoption scenarios in the industry as we start to move towards the 2050 targets of both fast, medium, and slow adoption. Another note as well is today's battery technology can't necessarily support college applications as well as it can utilize both utility and drilling applications. So that's something to keep in mind with this illustration. So I've got another question up for us here. What do you think can help accelerate the adoption of BEVs in mining? This is a word cloud, so if you do have a device and you can go back to Slido, that would be greatly appreciated. What do you think is getting in the way of adoption currently? What's your opinion on what could help accelerate that adoption? And if you don't think BEVs are ready, what do you think could help enhance that? Give you about 30 seconds there to finish your response if you're still brainstorming at home. So again, I apologize at home. You won't be able to see this on the screen that I'm sharing, but through your device, you'll be able to see the word cloud on Slido as I release this. So we've got some great input here. Availability of range and sizes of BEV equipment, robust, specific mining case studies, worker readiness, fleet subsidies, cost, training, financial incentive, regulations, variability and complexity of BEV platforms. You guys are seeing this on your devices, right?
Yep.
Okay, awesome. Availability of sizes, regulations. So it looks like we have some repetitive answers there. You can continue to contribute to this word cloud if you'd like, if you haven't had a chance to input anything yet. But some really good unique insights there. Thanks for contributing. I think the similar answers do get highlighted in more bold if you're seeing that on your device or not, but I'm definitely seeing regulations, reliability, safety, training, and education as some emphasis there. All right, so I'm glad two people have said training. I mean, I think that has been the most common topic of conversation that we have pivoted around today. And I think it's important to highlight the implicit costs when it comes to adopting new technology. Now, keep in mind, an implicit cost is a cost that's already been incurred, but not necessarily is shown as a separate or reported as a separate expense yet. Now, the human-centric approach to change management is of vital importance. If the people side of change is mismanaged, its project objectives won't be achieved. And this essentially does have a ripple effect and major cost implications in longer term. So from a short-term perspective here in this diagram, like a project, mismanaging the people side of change can result in delayed project timelines, can affect your budget and overall budget, can cause design rework and resistance amongst not only the project team, but different stakeholders involved within the project. When it comes to medium term, on an organizational perspective, there's also the effects of mismanaged change could result in lack of productivity, decreased value in employees, which would then result and impact customer expectations, suppliers, as well as could cause a saturation of change, which results, which is when an organization exceeds the ability to accept a change. From a longer term perspective, beyond the project and organizational impacts, there's also cost to consider if the change is not fully implemented. This could be a loss of investment or opportunities for others to invest, lack of revenue increases, lack of market share that ultimately could be captured if that change was carried out effectively. Now, applying change management on both a project and organizational initiative will allow avoidance of the costs and risks that last well beyond just the initial life of the project as we start to implement battery electric technology. So change is complex. We're all aware of this. It's not linear, but taking that complexity and then to be actionable drives the way we engage. Everyone looks at change differently, expects different things, and there are three things to keep in mind when approaching change: the individuals, the initiative, and the enterprise piece as well. Individuals are the people are the most are obviously important component. The initiative itself, so that's the organizational change. Why are we doing it? And then the enterprise piece. So why are we driving the change? How are we driving the change? And how are we going to be consistent to move to that future end state? Now, it is important to focus on the outcome in this off-highway industry as we are trying to move again from one state to another and break into this new market. Mining operators, OEMs, this industry itself is driven by historical norms and has been doing similar things for decades. And there are obviously misconceptions in this change. Ford's even had a study. People naturally do want to resist. Employees don't want change, and they do want to naturally resist. It's not a bad thing. But it is a fact. I think that that target was around 60 to 70% of individuals on average do want to resist change. And there's also a misconception that when you do have your metrics in place and your process in place, things will move forward. But it's not that simple, unfortunately. You do have to be quite perseverant throughout the entire process. Now, the most successful change efforts are those that are consistent across an organization. That includes clarity, communication, honesty, and authenticity. When it comes to the actual steps of managing change, we obviously have appointing a change champion or change manager. They're the ones that would essentially take the lead on highlighting the change. You're identifying what needs to be done, including implementation planning, utilizing different leverage points for implementing that change. And our two final points here are education and developing feedback mechanisms. There are so many unknowns around BEVs, and a lot of those unknowns do have to do with bridging the knowledge gap currently in the industry, and that comes with education. In addition to that, there does need to be an agile approach around developing and understanding ways to change the way we implement this change. Now, I'm sure we've all heard about this study, but some context around this. This is a retrospective example of a public case we can talk about where there's quite a lot of data around the perception of utilizing battery electric vehicles. And we wanted to talk through some specifics based on our research. Transition can be tough. Again, there will always be resistance. By simply swapping these diesel machines, it's not necessarily the answer for enhanced adoption. Keep in mind, the change isn't linear, and we do have to prepare our organizations for this acceptance through education and opening the floor to concerns, but at the same time, highlighting the pluses of the technology. So the outcomes of the Kittilä minefield study, this was done in Finland, was that there was improvement of working conditions. It resulted in reduced noise, heat, and increased air quality. There was an improvement in public image, and BEVs do perform better because essentially they are newer. From a negative side, from the perception of the operators, the efficiency of changing these machines and or charging the batteries did result in a lack of efficiency in their day-to-day work. The machines were too quiet. Obviously, we all know electric vehicles can be a lot quieter than diesel operating machines. There were some concerns around material availability. And these last 2 points here, last point after user-friendly, that could be an interoperability side. What kind of controls did they use? And lastly is the concerns about high voltage, electrical, and battery fires. Now, the consensus of this study in the Kittilä field mine trial was that there does need to be additional studies and research done to really know what are the concerns around battery electric vehicles. But I do think this is a good starting point. Now, having looked back at this study, the findings can hopefully fit into what I am trying to convey regarding managing change effectively. The hesitations or negatives from the mining operators is all around feedback and education and managing that change. It also should be mentioned that people are routinely focused on outliers, whether that be X and Y, dangers of high voltage, battery fires. I know there was an earlier presentation that had a question about automobile and electric vehicle fires. We tend to get fixated on a specific outlier, and it is important that there are support and training mechanisms in place to help stop creating those exceptions and implement how you're going to deal with those outliers. So when it comes to change mapping, this is a process we have taken both internally and externally with some clients, and it's a way of setting out to the future desired end state. This has been adapted from a guide on how to do theory of change, and I don't necessarily need to get into too much detail here, but the process, this is how you roughly carry out the exercise. So step one is you're gonna set out the context for the issue at hand. In this example, we've set out a fleet of new battery electric vehicles. We're introducing to a mine. Step two is we really want to understand our long-term outcomes that we are hoping from the change in our operations. We want to be known as what is safe, productive, and sustainable. Now, the rest of the workshop is going through inputs, outputs, and activities for what we can do now for our short, medium, and long-term objectives for desired future end state. With the inputs, again, these are just examples, but you want to assign the different people involved, change champions, upgrading machines, and color code both the green, so that's a project, and the blue is medium term, and then the darker green is longer term projects. And these are essentially abstracts of what the projects are and how the objectives you're going to carry out will get you there. This is just essentially a simple roadmap for how you want to get to where you want to be through change mapping. So I've spoken quite for about 20 minutes now, and we're going to take a quick break from me speaking to give you another question on, after you listen to me and everyone else today, what are your biggest concerns with battery electric vehicle implementation? Is it just education, or is there something else that maybe you can think of? Lots of participants, that's great, thank you so much. Hopefully you've enjoyed the interactive side of the presentation. You have 15 more seconds there. Sixty responses, that's great. How many of us are in the room?
45.
Many more online. Wow. Okay, so let's see our answers here. So biggest concerns around BEV implementation, obviously education, worker engagement, proper controls in place to prevent incidents, mine design plans, lack of resource attention, acceptance, that comes along with change management, great to hear, reliability, training, cost, safety, supply of equipment, power grid, emergency responses. Too many unknowns. There's definitely a lot of unknowns. Hopefully I highlighted some of those today. Energy terms, industry acceptance, capital, buyers, yeah, and that comes along with training, understanding how to navigate risk and high voltage. Underground performance, air, yeah. Operational readiness. Got some great input there. Thank you for those in the room, as well as those online that contributed to that activity. So I'm going to close out the slides with the quotes from Stephen Hawkins. Now, hopefully you've enjoyed my presentation today and understood how important from an organizational standpoint, there needs to be a commitment to change. We do work in a highly dynamic environment. Both OEMs and end users should be increasing their change management efforts to support not only the training, but also the feedback mechanisms and the entire process in itself, so that we are able to create a more sustainable environment and start to adopt these battery electric vehicles in much more volumes. So I'm going to end today's presentation with what are these companies, what are you doing currently to support this change?
Any questions or Alex? Go on here.
Yeah, I have one. Alexa, just want to go back to a slide you had earlier in your presentation regarding adoption rates in underground mining. I wasn't quick enough to take the note, but
Sorry.
if I understood, it was around 2035. I think you said there would be, yeah, that's the slide.
Yes.
Can you just talk about the data in behind this information and where you and Six Sync got this information, how you derived that graph with those adoption rates with respect to, is that EV technology in general, or is that EV technology in mining?
This is specific to Canadian mining.
Okay.
So we have taken a lot, this is all from public sources, but we're all aware of, you know, the ion mining guides as they release who's bought how many machines, what does that look like from when they're purchasing, buying, testing, then implementing the full fleet in the mines. So this is a guesstimation. Obviously, you can never be fully right in terms of what the numbers actually are. We're hoping it gives you somewhat of a feasible idea of where we are currently and where we will be as the industry starts to really flourish.
Because that's what we're seeing as an OEM, is really it's the larger mining companies that are, the adoption rates are quite high, the Glencores, the BHPs, the Rio Tintos and the Vales. But the mid-tier mining producers and small mining companies, they obviously don't have the capital budgets and so forth. So it's interesting. That's the first time I think I've seen someone attempt to put a graph up about the adoption rate. So I appreciate that. It's very, very interesting because on our side, it's understanding the level of investment you need to put in research and development, understanding where the industry is headed, and where to start your prototyping and product development. And you can see there part of the challenge for OEMs as well, right? We're talking about an industry that actually doesn't have a high adoption rate for another 10 years out. That's a huge challenge, whether you're an Epiroc or a Covaterra or McLean Engineering. That's part of the challenge is what we face as OEMs, is understanding the level of investment versus return. It's millions of dollars to build a BEV machine. And that's a real challenge I see in the industry. For the OEM side of it is the adoption rates are quite slow, really, when you look at that graph.
That's definitely, and it is just the current state of the industry.
Yeah.
We're hoping to amplify that as we all continue to work towards BEVs. But yeah, that's just different scenarios based on different sources and the reality of our current situation. But I feel as though visuals can show much more than just data or words on the screen, and I want to show it.
Appreciate it. Great graph. Thank you.
No problem.
Someone online was just wondering, is the adoption curve only like assuming underground mines?
Yeah, so currently there are very few fully operating open pit electric vehicles, if I'm not mistaken. That's like the large haulage ton vehicles, correct me if I'm wrong, are not fully operating to the same efficiency as underground vehicles that are smaller in tonnage.
And there was another person, I was actually on your app, so they did submit like a few questions
yeah,
there. I think one of them is a joke, but
Question from Art, right?
someone's wondering about the Ring of Fire and the BEV future there and your thoughts on that.
The Ring of Fire is in. Okay, so I was referencing Q. Very funny. Okay. Ring of Fire, you picture there. My thoughts. It's good insight. I mean, I think it just depends on what happens with the OEMs, the end users in the coming years. As we start to have more availability in offerings of OEMs for what is possible on the battery electric side. Does that answer your question? I'm not really sure what you mean
I'm
by
just
that.
thinking in terms of, they're debating the topic of small nuclear powered units for the ring of fire, the road, the infrastructure.
Oh, you mean it's
Great time.
storage?
Different tons, we'll just go electric and do the whole thing in one.
Yes.
Yeah.
Do you mean your question is in regards to energy storage and how are we gonna use that on the grid?
Oh,
Or more so like sustaining EVs
People
on
who
COVID?
are more knowledgeable than I am could speak to the ring of fire much better.
Okay, I just wasn't sure your question in regards to what you meant. If it was more grid based or automotive based
Well,
or,
No grid and, well, it's not even grid, because ring of fire could be its own thing. We don't have to tie it to a transmission line if we build in small nuclear power units.
this is true, yes, that's beyond my scope of
Go,
work, of technicality,
Time to knowledge up.
very true. How many batteries can a battery manufacturer manufacture? Battery manufacturer? I don't know if that's serious. I have a question here in regards to how many batteries can a battery manufacturer manufacture? I think that's a great question. I don't have the answer to that. I'll let you figure that one out. Are we ready to have enough energy supply to all BEV? Like mentioned, haulage isn't there yet. The technology still has its limitations from what I've seen. I know the battery experts can speak more to that, to their efficiencies. But yeah, I hope that answers that question. Is there any other questions online?
I don't know, maybe this isn't the right place to ask, right time to ask, but what about battery disposal?
That's a good question. I think that is more in regards to who is supplying the machines and or going back to the battery suppliers. I know some suppliers have a framework in place for what recycling looks like at the end of life of these machines. But I think it's a good topic of conversation in regards to what happens at the end of life that still needs to be really fleshed out in further detail.
Yeah, we've got another one on.
Yeah, there's two here. So someone just wrote thermal runaway. So I'm wondering, I think that they just want you to elaborate on that if possible.
Thermal runaway
Yeah,
in regards to change management.
well, I don't know. I don't have any more details.
I think we have some battery experts in the group that would be happy to talk on.
And, maybe we'll skip that one for now, but the other one is, can OEM keep up with these adoption rates?
I think it's a very tricky balance between the financial investment towards prototype builds, testing, waiting to get the results from that and validating that further, to then pushing that to production. In addition to that, the acceptance from the end user side. There's a balance on both sides of the industry that needs to be happening for these adoption rates, and until then, both the OEMs or end users won't be able to keep up.
Is there any more questions? In-house? Kathy?
There one just popped in. Has anyone looked at the potential exposure of workers to EMF? All these acronyms, I don't know.
EMF,
Maybe we'll get some clarity on that one.
environmental,
Electromagnetic frequency.
that's also something out of my
All right,
scope of work, unfortunately.
that's it for online.
So I can maybe speak a little bit to that. Part of our procurement requirements were for battery electric vehicles to conform to certain EMF, pardon me, requirements. I don't remember the number off the top of my head, but it was in our specification. So every piece of equipment that we're procuring rather, sorry, has to conform to that or better. So, and that's a whole bunch of testing and smart stuff that I'm not good at, but yeah, so all the equipment we're getting from Coverterra, McLean and Epiroc have to conform to that. Otherwise we won't be buying it. So it's one of the considerations that we've looked at for our equipment procurement.
Thanks for that. No more questions, comments? Great, thank you very much, Alexa. Just on behalf of Sylvia said for your presentation.
Thank you, appreciate it. Thank you.
So we'll get into our next presentation. So our next presenter is Brandon Vance. Brandon is a health and safety and environment consultant with NORCAT's advisory services. Brandon works with clients around the world to deliver compliance and risk management solutions in the mining, forestry, construction, and education sectors. He also works with internal and client subject matter experts to deliver talent and human capital customized solutions to improve talent management practices, training and development initiatives, and support overall workforce education and training. So please welcome Brandon.
Thank you. Thank you for the introduction. Happy to be here and speak to you guys today. My presentation is around preparing the next generation of workers for safe adoption of BEVs in the mining industry. I do have to say, all the presenters today set me up on a tee here. We're talking about training as one of the big challenges and how we're going to navigate that. So hopefully in this presentation, I give a little bit of insight on how NORCAT planning on doing that, as well as with our partners in industry and education as well. So just some numbers here to kind of reinforce that challenge that we're facing in mining in particular. Some labor market studies are projecting that 25% of the current mining workforce will retire, and roughly 80,000 workers will need to be hired before 2030. There are other studies that are saying the number is actually closer to around 100,000. So this really kind of emphasizes the need of getting all these humans into the mines and get them trained to a competent level just to fill the roles that are going to be missing. Now, if you consider some other factors such as the constantly evolving technology, we're looking at automation, we're looking at new processes, new equipment, and of course, battery electric vehicles. That just kind of compounds how much training is going to be required and the type of education that these workers are going to need to supply the mining industry. Other challenges we're facing with training and actually just the gap we have in the workforce is that mining isn't the only industry where this is happening. We need to get the right workers in. We need to get people the right skill sets before the other sectors scoop them up. So it's happening in forestry, it's happening in construction, it's happening in manufacturing. There's a gap in attracting young people into these trades and to get them prepared. So we have to be tactful and strategic on how we get them into mining. And so our current workforce must upskill to meet the industry's needs. The market for BEVs within the mining sector is increasing rapidly. Now that it's a proven technology, it's leading to a lot of companies accelerating its adoption. And this is something that we can't rush. It's something that can't be kind of forced. There has to be a good plan in place in order to properly implement these in order to be successful. So these are three kind of key priorities. There's much more topics we can go on and on for hours, but I'm kind of dividing my presentation up into these three sections. So one is on stakeholder collaboration, next a little bit on change management, and then third on education and training. So this is going to take all of us. I know we mentioned that earlier, and Tom emphasized that earlier as well. But for such a transformational change in the industry, we're going to need buy-in and participation and collaboration with our education partners, training partners, industry partners to get the equipment and get the material to site. And then we need our community partners, we need government to kind of get the bodies in the seats and to get people trained and get them, get everybody to a level where this can be safely adopted. There's been many examples of how this kind of partnership can work. I know in just some recent examples of work that I've done in our consulting, we work with the education partner up in Northern Canada, and they have industry partners that kind of deliver training, through their infrastructure technology and the sites they have. And then they work with their community partners, especially their Indigenous partners, to get people in there to, give them the basic skill sets to do these jobs. And of course, none of that's possible without government funding. So we're seeing a lot of that. And I'm hoping the next few slides, I can kind of paint a good picture on how we're kind of going to be supporting the collaboration across multiple stakeholders in all these different industries and different sectors. And this kind of starts a little bit with last July, there's an announcement of some funding. So FedNor invested more than $2 million to position Greater Sudbury as the hub for battery electric vehicles. So part of that money, Cambridge College received funding to establish their BEV lab within the Center for Smart Mining. So that will support the testing and demonstration of new technologies, new battery kind of equipment, and they do some testing and then also do some more training. And some of that funding also went to NORCAT to procure a battery electric LHD. So we're gonna use that to as well test, new technology, test different infrastructure that want to be put in place in the mines, and then we can integrate into our training as well. I'm going to talk a little bit about Core 5. So you see Core 5 was one of the sponsors event here, but this was kind of started up by the Ontario Ministry for Economic Development, Job Creation and Trade, as well as with the Ontario Vehicle Innovation Network. So Core 5 kind of just recently launched. We're excited about this. It aims to develop an ecosystem that's going to enable the rapid development, testing, validation, and commercialization of industrial BEV technologies across value chains. We're focused on critical mineral extraction by leveraging unique assets, resources, and service offerings from partners all across Northern Ontario. So they're setting up these kind of networks all around the province, and Core 5 is really the northern ecosystem that we're kind of putting together to be able to provide services to manufacturers and research firms, new innovators to get their kind of products into the industry. So our strategy for the Northern Ontario Regional Technology Development Site aligns closely with Ontario's BEV automotive strategy and the direction of Ontario's critical mineral strategy. So these are the three main kind of offerings within Core 5. So we have the open innovation ecosystems, the development, testing, and commercialization of technology, and then we have our RIC Center. That's the Regional Innovation Center, Services and Resources. So I'll go through each of these in a little bit more detail. The open innovation ecosystem is an online technology platform and a global marketplace that's going to connect the builders and the buyers of new innovation, new technology, to help identify and accelerate the development, testing, and deployment of these solutions. There's 5 key regions responsible for building this ecosystem in the north, and here they are. And it's going to host an inventory of available supports, key contacts, main challenges, gaps, needs, wants, and technologies and potential solutions. So I encourage those companies and those people that are trying to get their products out and service to really reach out to Core 5, and we direct our clients to you, and it's going to be a place for sharing. Secondly, for the development, testing, and commercialization of technology, we're going to be able to provide resources, specialized equipment, and infrastructure to these companies. So that's through Cayman College's BEV lab that I mentioned earlier. Canada College has a center, and that's in North Bay. Northern College in Timmins has a center, and then of course NORCAT's underground training centers. These are spaces that are going to be available to our clients and to our partners, where they can go and test their equipment and get it, commercialized and ready for the industry. And thirdly, with the RIC Center, so this is where we provide startups and newer companies, tech companies, to connect and grow and scale their business. So with that, these are the kind of the 5 key service offerings. There's advisory mentorship services available. There's co-working spaces, there's education and workshops, and then there's capital services, access to investors, and then networking events and buy and sell days. So these are the main partners that are involved in the Core 5 that I mentioned a little bit earlier, among some others, and then some available resources that are available to them. Though that table shouldn't be highlighted in colors. Those are like kind of 6 different services and resources that are available to people. So if you want to test your equipment using 5G connectivity, we have that ability. If you need lab space, there's over 70,000 square feet of lab space available. There's a test track for new BEVs. So these are all things that we can offer for companies that want to test their equipment out. All right, so if there's any questions around the Core 5, I'm going to direct you to Justin Lauren at the end of the presentation. That was his thing. He's part of our innovation center at NORCAT. But hopefully that kind of painted a good picture on how we're planning to collaborate with all the different stakeholders and how we're trying to develop an ecosystem to help each other out. It's not us versus them, it's all of us, and hopefully we can provide good resources and good services to everybody as they adopt BEVs into their organization. I want to talk about change management really quickly. I know Alexa so eloquently kind of just went through that process with us. I don't want to be too repetitive, but I do think it's important to talk about change management a little bit before I get into the training, just because training is a key component of change management, and there are building blocks that need to kind of be in place before you start training. So I kind of want to get that message across before I jump into it. First, going to start with a quick term on change fatigue. So that's just a function of change capacity and change disruption. Your change capacity is really just your willingness and your ability to want to accept change and your need for the change. And then your disruption is affected by a number of factors and the changes that are going on and the disruption that each one causes. I think lately, a lot of organizations, not just in mining, we're facing a lot of this change fatigue. There's too many changes. We had the pandemic, we had all these new things, there's new technology, there's new forces, trying to speed up how we're kind of adopting this new stuff. And I think people are getting tired of it. So it's something to acknowledge that's out there. We talked about resistance, but people don't want to change. So it's important to kind of understand that in the beginning and think of strategies how we can avoid that and manage that with people. There was a good study that I came across. There's a consultant in BC who did some work with different mining companies, and they looked at new technologies that were implemented. So it's not just BEVs, but they looked at automated equipment. They looked at monitoring and compliance technology that's in the mobile equipment. And they kind of identified some of the key factors and key reasons why changes either failed or weren't that successful. So here they are listed. So lack of senior management support, a lack of a communication plan, not communicating to all your stakeholders, and then a number of factors related to training. So lack of attention to training, not training everybody, and then leaving training at all levels just to the vendor or manufacturer. Not taking any ownership on your own training, your own organization, and integrating your own processes and stuff like that. So these are some of the challenges and the reasons why change fails, and some of the factors on how change management can be effective. So you need proper leadership support, you need your worker involvement, you need supports in place within the organization, and then of course there's some notes on training and procedures and risk assessments as well that need to be in place before you get people trained, before you get this equipment will go. Leadership support. I think the key thing here is just having that empathy. The change needs to start from the top, and you need to kind of think about that culture. When you're thinking about change management, you're thinking about the human, right? The human element and working with people. So understanding how that change is going to affect everybody across all levels of organization. It's not just a money thing. It's not just a sustainability thing. This is going to change their day-to-day tasks and day-to-day work activities, and it's important to acknowledge that and understand that in order for everybody to kind of be bought in. Workers should be involved in the solution. Identify your change agents and your squeaky wheels. So these are your people that kind of voice their opinions a lot. You have some people that are super adaptive and really accepting of change, that are super excited about this stuff that's coming in. So you want them involved. They might have some great ideas, and they're going to be good advocates for the change. But your squeaky wheels are really important as well. And those are your grumpy guys. Those are your people that don't want to change, that are going to voice their opinions, that are going to be less willing to, they're going to be a lot of resistance and be less accepting of change. But they're really important to get involved in the process as well. Usually those people, as much as they make it difficult to communicate with, they usually care the most. And the reason why they're so grumpy is because they just want to see everyone succeed, and they think they know the best way of doing it. So if you get them involved in the solution, you let them be heard. And if you not necessarily change them, but if you listen to them and they understand your initiative, they're going to be greatest advocates for you. And of course, your impacted operators and maintenance personnel must be in the know. These are the people that are going to be working with the BEVs day in, day out. They should be involved in the process early on. Organizational support should be put into place. And then just an example here, the communication plan. I know Alexa talks about having a change manager and having a really good strategy in here, but communication plans is really important. You need your senior leadership to provide the reasons for change and why they're doing it and why it's beneficial to everybody. And then you need your supervisors and your mid-level management to kind of really support the workers and include those "what's in it for me" answers. Workers need to know why the change is going to impact them, why it's important for them, why they should do it, why they shouldn't do it. Those day-to-day things that are going to really kind of ease the transition a lot more smoothly. Use face-to-face communication as much as possible. You get those corporate emails or you get the bulletins, and they're not as effective as hearing it from face-to-face communication. So that should be done as much as possible, and repeating the key messages. As for training, before training starts, it's important to establish your training requirements. So if you know what type of equipment you're getting, who's going to need that training, what kind of training are they going to require, how's it going to affect emergency responses. These are some questions to ask before you kind of get into it. Workers should know why this is happening, the benefits of adopting BEVs. It's just one of the strategies when shifting to electric mine and getting them to embrace the benefits. And then change can be hazardous or not communicated properly. That's why training is going to be super important. They need to be able to feel safe. And we'll dive deeper into the training in a bit. Procedures are going to need to be revised or redone or rewritten. I mean, you adopt new technology, new equipment that should be done before you get it, or, you know, as you're procuring it and getting it on site, but before people are being trained. These are just a list of examples of the procedures that are going to be impacted once you get a new fleet of BEVs. So your inspection procedures, your startup shutdown procedures might change. Some operating procedures, of course, now you need charging procedures, new charging stations, how to work safely around them, storage for batteries, how you're going to handle batteries, things like that. So just some things to think about, and getting the right people on board, getting your SMEs involved in the process, have some workshops, develop your safe work practices, develop your SOPs, whatever fits your organization. And then, of course, training on these procedures and communicating them effectively in order for them to work. We talked about risk assessments quite a bit. I'll just point a little bit to the health and safety risks. As things get rolled out properly, I think it's really important to do a lot of risk assessments on the various tasks. So do some JHAs, do some JSAs on the various tasks with the people that are working with the equipment. And I'll just provide them more resources, more tools in order to kind of feel safe about it. And something, when an issue arises, they're going to have a resource to kind of fall back on and something to point to in order to kind of navigate that challenge. So that same kind of reference I was talking about earlier, that study, they provided a pretty good framework for change management that I thought was pretty good. There's some 4 steps, of course, there's so much more involved in that. I tried to just kind of highlight a few key points for each step. But when you're preparing for change, that's when you're going to be assessing the organization's current state and its ability to change. You can kind of identify or assign like a risk profile to your organization based on how big the change is going to be and how kind of ready your workforce is to accept it. And that can kind of guide you along on how much work is going to need to be done in order to kind of, proceed. And then you're selecting prepare a change management team. Your change management team is going to be the ones that are kind of, develop the strategy, see it through all the way through to implementation and evaluate kind of its success and identifying gaps or issues. When you're planning for change, is we're going to be preparing your change management plans. So that can be your training plans. So doing a training needs analysis, identifying who needs training, when you're going to be doing training, who's going to do the training, how long the training is going to be, all that kind of stuff. You're going to be building communication plans. So how is this going to be communicated to all the workforce? Who's involved in the communication? When are they going to communicate it? How is it going to be communicated? And then, of course, your evaluation plans. You want to make sure you're evaluating it all the way through to implementation, so that you can see where your issues are and where your successes are. And that's when you're doing your implementation. So you'll measure your progress, identify your gaps, resolving issues, and then manage any resistance that may come into play. And then do your evaluation. So you're gathering your feedback on your successes or failures. You're auditing for compliance, and you're just making sure the strategy is being followed. So I thought this is a pretty good example. If you wanted to learn more about it, there's that reference there. You can look it up. I thought it was a great tool. All right, and now finally the guy from NORCAT is going to talk about training. So obviously, depending on where you're at, whether you're a mining company or you're a consulting firm or you're a mine manager, your supervisor, there's some challenges that are involved in training on BEVs. So obviously, since technology's been around for a while, but not many places have fully adopted it yet. So when you're thinking about training and what you have existing in place, there's a lack of experience. You have your trainers and your go-to people who usually do this. It's new to them, right? So lack of experience on BEVs, lack of existing knowledge on BEVs within the workforce. We talked about the lack of training standards a little bit today, so that's a huge drawback, big challenge, and that came out in Alexa's quiz as well when we talked about it. Development of new work practices, new procedures, that's a large endeavor, so that can kind of, be challenging for people as they kind of go through this adoption, how they're going to train people. There's a ton of new things to train them on. It's not just you're getting this equipment, let's train them on that. There's so many different layers to it. And then there's cost. I'm going to kind of look at it from 2 different lenses. So training the existing workforce that you already have within your mind, and then training the new workers. So first with the existing workforce, it could involve some relearning some principles. So some of your experienced operators, they're going to need to relearn how to do some things. They're going to have to learn new skills. They're going to have to reskill a little bit, which can be a challenge. But here's just some high level few things that they're going to definitely need to be trained on. And that's the operating differences between diesel equipment and BEVs. Definitely the safety concerns that are specific to BEVs, which we talked about quite a bit today, thermal runaway and fire and electrocution. They'll need to be trained on charging safety and charging procedures, and then all different maintenance activities as well. And this is where I think Cambrian College really steps in really well. I know College Boreal has a similar program, and there's others across the north too, but I want to just highlight Cambrian's newer program. It's industrial battery electric vehicle certificate program, where they do so where they are training heavy duty equipment mechanics and learn how to do the maintenance on battery electric vehicles. It's not only for kind of new prospective mechanics and technicians and college, typical college students, but they're providing opportunities for the workforce to kind of come in and upskill and relearn this new technology. So your experienced mechanics can go to Cambrian and take some courses and then get more certified on doing work on BEVs. Some of your operational practices that are going to differ when you move from diesel to battery electric. Your inspection criteria are going to differ. Your startup procedures are going to change. Depending on the make and model, your operator interface and some of the alarms and some of the ways that the operator interacts with the machine are going to change. Emergency procedures may change as well, just due to the different risks or things that are in place. So something to consider there. And then of course the performance differences, which we talked about a little bit today as well. So lower noise levels, the higher torque output, higher maximum speed, regenerative braking. There's some different operating parameters here that are going to take some time to get used to. And then it's not just good enough to have a training package or be trained on BEVs in general. There's going to be so many differences amongst manufacturers and amongst different models. We talked about GMG a little bit. So the Global Mining Guidelines Group, they put together a really good document, a great guideline, long PDF. That's a good resource. I encourage people to kind of look at that. It's about just implementing BEVs into your operations. And so this kind of table is taken from that, and just a good example to tailor your training to the role. So you look at your different roles that you have, and it's important to conduct a training needs analysis. So identifying what the roles are, what are the main tasks, what are the job descriptions that that person has, and then break it down further into the key competencies. So what are the main things that they need to do? What are the skills they need to have in order to do those tasks? And then that can paint a really good picture of what sort of training they're going to need. So it's a fairly extensive process, but just from a, in a nutshell, conducting a training needs analysis in the onset will really give you a really good roadmap to get everybody competent and certified and authorized to operate and work around BEVs. I'm not going to go through these. We talked about this a ton today, but when it comes to training the existing workforce, it does present some unique challenges, unique hazards. So that needs to be definitely involved in your training as you're developing that, particularly to fire, electric shock, arc flash, charging systems. And then for your maintenance personnel, there's some new terms here on side discharge, faulty discharge, over discharge. So this is just some key content that should be developed that needs to be kind of relearned to the people that are working with this and performing service and maintenance on the batteries. And then of course, they need to be understood that with the operational differences come, training on how to job plan. So we talked about battery swapping and time to charge and versus refueling. So this is going to be unique to of course, the equipment that you have and your procedures that are in place at your workplace. But just another consideration when you're putting together your training plan is that there's some operational considerations take place. And if you're not an operator or you're not a maintenance person, but you're working underground or you're working around machines that are moving, I think it's really important to have at least an awareness course in place for everybody. Some BEV awareness, just so they understand what the unique hazards are, and they have some knowledge about them, even though they're not operating and working around them. You find yourself in some tricky situations. Due to the quiet operation of BEVs, you talked about that. It could present some more, higher risks for struck by incidences and collisions. So maybe some communication protocols need to be updated or revised and or retrained. And then handling and storage of batteries. So I think a BEV awareness course is critical to anybody that's going to be working underground as you shift towards this being more prevalent in all the different mines. And then now when it comes to training the new workforce, the new people that are coming in, I think this is great. This is a really good place where NORCAT can step in with our Common Core training that we do. What's great, they don't have any, established procedures to relearn. They're learning, they're coming from ground zero. They're learning skills from a very basic level. And so it's a good opportunity to give them that training and education now, before they kind of get into the workforce. So I'd love to see how BEV integration can, BEVs can be integrated into Common Core. So I'm going to talk a little bit about how I see that and what kind of steps are in motion in order to achieve that. Again, we're really early with this stuff, but just some thoughts of mine as we kind of go through it. So at NORCAT's Underground Center, we do deliver the Underground Hard Rock Miner Common Core fairly regularly. It is a 5-week course. They get all their basic modules, and then they do a number of specialty modules, including module 10, which is muck with LHD. And as I said earlier, we are procuring a new battery electric LHD, and we're really excited to get that later on in the year, hopefully before Christmas. And what we're trying to do now is see how we can integrate that into the training. So right now the workers are doing, they're spending about 3-ish days on a scoop and learning how to operate a diesel LHD. And we're looking now at updating our curriculum to integrate the BEV education. So we're looking at all the different modules, all the different components of that training. So with the pre-op checks, we're going to make sure that all the different considerations are in that pre-op checklist, and they're getting information on what to look for and what defects are available to, or they could find, how to safely inspect them, what to touch, what not to touch. Safety, of course, all the different hazards and ways to work around them. The machine components need to be updated, your operational checks and some operational differences, emergency procedures, and then some shutdown and charging procedures. So we are going to be working with the manufacturer that's providing it to us to develop some of the stuff, and we'll be integrating into our curriculum so that our trainers first understand how to do this, and then they can teach the young people as they hop on a scoop for a couple of days. They can see the difference between diesel and battery electric. Down the line, we'd also love to have an introduction to BEVs course or something similar. Maybe it's called the BEV awareness, where they it's not specific to LHDs. We're hoping in the future we can get a number of new battery electric equipment, and they can kind of get a new flavor and a good sense on how to just operate anything that has a electric battery. So that's kind of down the line, wish list type thing. I'll spend a little bit of time on curriculum development. That's more my sphere, my day-to-day stuff. I don't want to get too into the weeds with this, but it's really important to integrate BEV education into your traditional in-class, like your theory training, and then in your practical in-the-field training. So, if you follow some training standards, whatnot, it's great. It's a great guideline. And then you kind of see, in modular format and the progression of your training, where to kind of put in some of that BEV content, right? So like anything when you're developing your curriculum, if you're a health and safety coordinator, or you're a training manager, or you're a trainer yourself, this is just kind of some best practice stuff when you're developing your training. So take into consideration any applicable legislation, take into consideration the OEM specifications and the operating instructions. We have McLean here, we have Epiroc here, we have other manufacturers that produce really great manuals that are to be used as a great tool and resource. Read your manuals, but reading the manuals alone isn't training. That's just reading. So it's important to kind of integrate that into your training and really know your machine that you're operating. Leverage your SMEs. I am not an SME, even though I'm a content writer and a curriculum developer. I don't pretend that I'm an expert in operating this equipment. I like to stay away from the equipment. That's why I did my time at university, to avoid operating the equipment. So leverage your SMEs. It's really important. If you don't have SMEs that are available to you, I'm really lucky at NORCAT to have a number of really experienced operators and people that come from all different walks of life, that you vet your material, you make sure that they've reviewed it, they understand it, they give you really good information, and it's a really comprehensive package when you have people that have done the work verify what you're putting together. So leverage your SMEs. If you don't have SMEs available to you, I just talked about Core 5. I think it's a great place to go. And then of course our education partners and our industry partners, and seek them out. We're all in this together kind of thing. And then always integrate your site-specific procedures, especially if you're talking about lock and tag, zero energy. Always important to kind of put that in to make it, put that ownership on your organization, make the training specific to your operations. I could talk more about that, but I'll stop there. So now that you have your curriculum kind of developed, you have your training integrated with BEV information, Really important to train the trainers. So a lot of times people that are making the training programs aren't necessarily the ones that are writing the training. So it's great that handoff needs to be done properly. There needs to be a good strategy involved with that. So there's some frameworks involved in doing train the trainer. You have the subject matter expert work with you to deliver it first. You do kind of a co-teach, and then the new trainer will deliver it again. But really important for that trainer to understand the material, and then understand the training requirements. So that needs to be taking place. If you have a lead trainer at your organization, getting them to kind of make sure all the different trainers are aware of this and follow the same processes. It's always, leading practice. And if we're successful, and if down the line in the next year or so, we are successful in integrating the BEVs during the Common Core training, and down the line, if standards are updated, as we talked about earlier, I think it'd be really beneficial to all the different mining companies. It's going to make the trainings more appealing to employers. It's not gonna be the first time they see it when they go to their workplace and they're operating a battery electric vehicle. They're gonna have some experience in it when they took their Common Core. So I think that's great. Should reduce some onboarding training and speed up worker readiness. And then they're already aware of the benefits of BEVs and the importance of change. If we do this properly and we do this successfully. This is just some things that I have to plug a little bit, and I don't even have the authorization to even say this. This is my wish list, my personal wish list. we have a really great simulator lab at NORCAT that is truly unique and is used quite a bit. But and that's that picture right there where you're operating in different machine. That's a whole truck or a scoop or something. It would be great to get a BEV in there so that people can kind of get an understanding of the differences in operating a battery electric vehicle as opposed to diesel vehicle. We have a virtual reality circle check training module, which is excellent, where you're in the Oculus, you put on the headset, and you can do a full walk around of multiple pieces of equipment. It'd be really great to have a a BEV in there so that they can inspect the battery component, battery components if they could do so, and really understand the different kind of machine components compared to traditional equipment. And then use the FIR for fire expression. So the FIR is our augmented reality fire extinguisher training tool. And it's really cool. You can give people fire extinguisher training, how to use it appropriately in augmented reality using like a tablet and a real fire extinguisher. It'd be awesome to have a BEV that can be blown up and put on fire, and then really understand the challenges in putting some of that stuff out. So that's kind of my wish list. Sorry, NORCAT, but I'm gonna be pushing for this one when we get there. So I'll end there and take any questions. Thank you for your attention.
Any questions from the floor for Brandon?
Well, Common Core has come up a few times now in regards to BEVs. And we've discussed for the future to having Common Core include BEVs. Would it be safe to say that people that are already got their Common Core, have their Common Core for years, would they be grandfathered in? Would be expected that that module would be able to operate a BEV?
That's a good point. It's a good question. That's gonna be up to the ministry, of course, as they're the ones that make final approval on those things. I think it makes sense to just give them like a retrain, like not to take their Common Core
No,
again.
just one module like that.
Yeah.
And that's what I wondered if would be required not if any talks about that.
I can give you my opinion on it. I don't know what's gonna happen, but I think it would make sense to just have them kind of redo some training on that equipment and then get to be certified on that BEV specific, and then they get their ticket again. But who knows how that's gonna work.
I can answer a little bit
Yeah.
of that. So the Common Core, the modular core program in Ontario it's a demonstration of skills, right? So the lesson plan or what the scope is of training is on the employer's end. So the specialty modules for whatever they be, operate, screw tram, operate. They are elements for which the employer intended for the employer to design their own training plan for that, right? So the demonstration of skills around battery electric vehicles, we spoke to it earlier. There's a scope of work there that is becoming desperate to get hashed out and get a subcommittee struck to run it. And we're looking at that as mining tripartite committee. We have a meeting coming up in 23rd, February. So 2 weeks. Yeah, pretty good point. It keeps coming up. Needs action.
Gavin, read one online?
Yeah, we have one online, a technology question. So with battery electric equipment being in place at places like Kirkland Lake Pool for years now, what key technology gaps are still being researched? And so it's not exactly a training question, but
Yeah. As far as technology gaps, I'm really not aware of any right now. I think the manufacturers are doing a lot of work to get these things to be as dependable and efficient as possible. So I'm not really aware of those. I think it's more in the implementation side on the barriers and gaps and actually getting them on site and then making sure they're implemented properly. But I'm not aware of any research right now that's going on. Fire is obviously a huge thing, so maybe future research on how to prevent fires from happening or how to properly and adequately extinguish these fires should be another research focus, but I am not aware of any.
Thank you.
That'd be my wish list though.
So question back here, Norm, do you have a question?
I was just, he followed up with
Oh,
the specialty modules. I think it'll be important at the sites, train their people on any changes to the equipment they have.
okay, another question here?
I can ask after Paul. Okay, thanks again. I was just gonna say, you said 80,000 workers need to be hired by 2030. What are your thoughts on like automation, reducing the number of new employees? Do you think there's opportunity there? Or do you think it's just displacing the skills, like changing rather, you're not gonna have a truck driver, but you need somebody that can maintain the autonomous system?
Exactly. It's kind of like the composition of those workers. I think they know that there's a number of aging people that are going to be leaving the workforce. What role are they in? I'm not sure. They'll need to be replaced, and yeah, with automation, it might help some of that. But again, you still need people that are going to operate those remotes, right? Yeah, it's a huge challenge ahead because not only are the people retiring, but we need these critical minerals to keep up with the demand. So there's gonna be new projects opening up, and which needs to hire more people. It's just there's so many factors in play. I don't know if there's a real solution for it other than trying to get people attracted and willing to get into the trades. I think now that mines are getting cleaner and getting greener, it's a lot easier to sell to young people to get into mining. I think I'm not that old, obviously, but I know growing up, there's a not a fear or a stigma attached, but it's a dirty job. It's dangerous. You're exposed to all these things, and we're getting so much safer and it's getting so much cleaner. I think that communication needs to be done at the high school level to encourage people to get, hey man, these are high paying jobs. You're gonna have a great career and it's really safe now, and you're not exposed to the same hazards that you were 40 years ago.
I totally agree with that concept. I mean, you look at all of us in here, we've all started probably at the coalface, so to speak.
Right.
Look at the careers we've been able to achieve in the mining industry. So it's not all dirt, doom and gloom. And as you mentioned, the industry is getting cleaner, getting more attractive. So that we have to start correct at the grassroots level, and that's in the schools and colleges.
I was steered away from going into mining, right? And now we need to actually promote it.
Well, you kind of mentioned it. You went to university to avoid driving.
That's not a slight at all. That's just my dad's a tradesman. My dad's been working in the mining industry, and my message as a kid was, you're gonna go to school and you're gonna stay at school. You're not gonna do what I do, kind of thing. But now that attitude has changed. We need people in the mine, and it's not a dirty, dangerous job as it is.
It's about the marketing of the industry. It's changed so much. The careers, there's virtually anything that you can go to university for and get a degree in. You can work in the mining industry with that degree.
For sure.
We still need tradespeople. We'll still need people to operate. It's about the marketing and the benefits and where that initial job can take you career-wise and lifestyle-wise. I mean, look at the lifestyle we got in Sudbury. People ask me, why did I move to Sudbury? It's freaking awesome. So,
Another question just behind.
Just around word delineation. I don't know if I pronounce that correctly, but I was talking to ministry, like there's nothing says like what electrician gonna do and what heavy duty mechanics gonna do.
Okay.
And I get the answer from ministry that it should be competent person. That's up to the mines itself to figure out the competent person, how you are going about it to figure out who's supposed to do what.
I think it comes down to really understanding the jobs that are required, and I don't know anything about that right now as far as the maintenance activities and the service activities that are going to be taking place. But I think from a high level, just understanding what the various tasks are, breaking it down and what skills are required for that. And then as long as the training or the education can align with that, I think that's where your kind of delineation can be, but that's a tough question. And
That's what I think everyone's going through the same thing.
Yeah.
It's like, who's supposed to touch what, and what's the better limit of electrician or heavy duty mechanic or the electrician, where someone come into.
I think with the CSA standards kind of coming in now, and then some more, industry standards coming out, that should verify some things. But yeah, that's tough.
There might be a lot of cross trades coming from this.
Well, for sure. Well, and yeah, if you have the heavy duty equipment mechanic, program now that they have the electrical vehicle component to it, those are gonna be your specialists. And whether they're, it's a good electrician background or I don't know.
Yeah.
That's tough.
No, we're good for online.
Well, two questions. First question is, can you speak more to the LHD BEV that you plan to acquire later this year in more detail or no?
Not really. I know, I don't know if I can say more about it. Yeah. We're hoping to get it in the fall. Right now, we have two really small old LHDs. So just getting anything is going to be a great improvement. We're super excited about it. As far as what specific features or making I don't know.
And I have a second question on top of that. So what is NORCAT doing? Like, through what I have seen, a lot of these college programs are typically backed by specific OEMs.
Okay.
What is NORCAT doing to stay ambiguous to one specific machine type or one specific product offering versus the interoperability across the industry?
Oh, we're definitely not tied to, we have partnerships in various different levels, and with different manufacturers and different education partners, but we don't have though. It depends on the program, it depends on the service offering, but I think what's unique about NORCAT is we have our innovation center and we have our various departments, and we're not just training. So we have consulting, we have innovation, and so we work with startups all the time. So we're always working with new companies. We're always trying to pivot and adapt to what's the new, what's the best thing, and we're supporting these companies. We're not kind of closing ourselves in on one thing. Does that kind of answer your question?
Yeah, okay.
Okay.
Questions?
Yeah, just observations. It's interesting. Look at our gender split here. We're going to need to tackle
Yes.
that topic.
Yes.
And obviously, the
Good
second
call.
one is we need to reach high school guidance counselors
Yeah.
who have been guidance counselors, some of them for 25 years. They know nothing about this business.
Yeah,
And
exactly.
here they are in Sudbury. And I'm shocked when I come across a guidance counselor and I say, what about the mining industry? And
Yeah.
they say, what about the mining industry?
Yeah.
They have no knowledge. So I think one of our biggest outreaches is to educate teachers, guidance counselors, principals, vice principals, the board of education.
Agreed. Yeah, agreed. And just even on your first point, looking at the the diversity in mining, I think I'm actually glad you asked that question. I have a chance to kind of talk a little bit about what we're doing with the Future Skills Center. So we're actually working with different community partners and education partners, and we're attracting a lot of women, a lot of Indigenous people in our Common Core program. So we're capturing all this data on their socioeconomic backgrounds. We're tracking their employment status. We're looking at after they graduate, after the 5-week program, where they're getting hired and where these employment opportunities are taking place. And so we're seeing a lot of really good numbers in that. I think we have over 30% of our students in the last year are Indigenous. I think around 20% are women. And so exactly the women and those lower, the diverse populations need to understand that mining is for them as well too.
Any other questions for Brendan?
Not a question, but a comment on that. I know in northern Quebec, what they do is like every student have a full day in the CFP where they can try all the mining industry trade. Yeah, And it's like a competitions where all the kids try everything, so they try
Okay.
mining simulators and they try like mechanic and.
Like a student recruitment thing?
Yeah.
Okay, that's cool.
So maybe that's something that I think it started by there
Yeah,
to recruit those.
I know there's a few schools here in Sudbury. I know Lively High School is really doing some great work to kind of get the students involved in mining. But yeah, no, that's gonna be great. That's gonna be huge. Get
Thank you very much.
Thank you. Oh, excellent. Fair enough. Yeah, good.
So we'll get to our last presentation for the day. So dealing with the sponsor, so Levitt-Safety, so Derek McEwen is a market segment manager at Levitt-Safety for 30 years, in various facets of fire safety, and 12 years with Levitt-Safety. So Derek has focused his involvement in fire suppression and protection solutions, mine rescue, service and support, sales support, product management and marketing nationally in his current roles. So Derek is in person. Okay, and then virtual will be Danny Cazares, who's a project manager for detection controls with Johnson Controls. His background is in radio frequency technologies and electronic engineering support. His roles have evolved from sales site engineer, project manager, and now to project manager for Johnson Controls. So please welcome Derek and Danny.
Well, Danny, are you on?
Yeah, we're on.
Excellent, thank you. Thank you. And thank you to the presenters that went before me, really kind of built this up for me a little bit. I feel like I'm a little bit in the hot seat, so to speak. Lots of topics here that are going to be good to cover. So Levitt-Safety is our goal and mission statement is to be your partners to solve any solutions that you have in regards to your fire, environmental, or safety concerns. So that's where we'd like to start off, and that really moves us. Did we miss a bunch of slides here? Maybe. That's okay. We'll improvise. So yeah, as a whole, as this topic goes, the BEV side of it is kind of a bigger topic. We worked on a solution with our partners. We are a distribution company that works with manufacturing partners to bring different products and solutions to the workplace for instances like this, where we have new technology coming into an environment that, we don't necessarily have risk mitigation plans for already. Some of the great things that are out there, though, are OEMs that are building inside of that engineered, designed plans or mitigation risk analysis, so that we don't have to necessarily worry about some of the really bad things that can happen. Danny, it looks like we're going straight to you here right away. Oh, I just didn't click far enough ahead. So, as Levitt-Safety, I spoke about this. We are your partners. That solution side of our business is really built on a lot of what we have to offer. So, services and products can meet each other to provide something that brings you something like a fire prevention plan when you have something like a lithium-ion batteries in your workplace. So, as you can see, there's lots of different things that sort of encompass Levitt-Safety as a whole. There's lots of dangers that come in a workplace with fire risk. And I don't want to be a fear monger here. I mean, we talked today that there's lots of good engineered, what would we call them, Andre, like you guys have developed lots of different aspects in that to prevent a fire from even happening in the first place. But bigger picture is we know that events happen. So low probability, but when something does happen, it happens and it's bad. So we're just going to try to develop a little further on our solution to how we can make it even safer.
I want to kind of address that topic, which, has come up a couple of times with fire and how do we suppress these things or extinguish them? So we're really aiming at a moving target here. There is not like the NFPA, there's lots of different guys that speak into this on different levels when we talk about the typical diesel or ABC firing in the workplace at any level. Sorry, excuse me. That's all good. So when it comes to lithium-ion battery fires, we know that there is no true method of extinguishment. What we have is some ways of suppressing. And when I say moving target, I say that because different people have different approaches. And it's going to depend also on how you or what happens in your workplace. If you're addressing this from a mine rescue standpoint and you're the first on scene and it's up a ramp, you have a different way of attacking this or approaching it than if it's in charge state in a controlled environment. So you can use different aspects of it, and that really kind of means that everything from typical water approach, drown. And I read recently from a Tesla S-type manual, 3,000 to 8,000 gallons of water are required by their manual to put out a fire. Even after that, 24 hours of watching that battery to make sure no reignition occurs, you can then turn it over to secondary, like a tow truck, and still say there's potential risk that fire can reignite. So when something happens, it happens and it happens bad. So we're going to try to give you guys some solution to contain, first of all, when something does happen, and try to find early detection so that you can prevent these things from happening if they do occur. I think I heard very earlier on, somebody asked a question about the off-gas. And that's where our friends at JCI are going to take over this presentation for a few minutes. Danny, do you want to go?
Hey, Derek. This is actually the other Derek from Johnson Controls. I was able to rearrange my schedule, so Danny was willing to pinch hit for me, but I was able to make it. So as an introduction, right, my name is Derek Sandel. I'm the global product manager here at Johnson Controls. One of my products that I brought to market is the one we'll talk about today. But I also then oversee portable fire extinguishers, restaurant systems, and then Danny is actually on the team who is working, investigating, researching, and developing solutions for battery electric vehicle, off-road battery vehicle electric fires. So Danny's working on that team. So as we get through this presentation, if there's questions, right, both Danny and I can chime in and help. So with that, lithium-ion batteries are all around us. As you guys know, cell phones, they're progressing from everything starting at the coin cell level all the way up to battery systems that are, many, many megawatts of batteries. And the bigger systems, as you scale it up, present a much higher risk of fires or thermal events, which are low risk, low probability of occurring, as Derek mentioned, but the risk is very high when you have that amount of energy stored in a very small, compact space. Next slide, Derek. I just wanted to show a snapshot here. This is from Factory Mutual in the United States, out in Boston. They did a series of tests, and you guys could go and look at YouTube and find these videos. This is just a example rack of fixed energy storage batteries, and they purposely set one of the batteries to thermal runaway in the bottom left corner of this rack. And then they went through various modes of trying to control it with fire suppression. And ultimately, the outcome of that was there's considerable amount of heat release, and fire suppression today, the technologies that exist in the market really only at best control and reduce the amount of heat being released from that fire, but don't have a very good probability of extinguishing these fires. In this situation, this is in a rack. If you think of it in the mining scenario where you could have this in a large battery off the side of a mining equipment where it's packed even higher density, the probability of getting that fire extinguished is probably even lower than this situation in racking. Next slide. All right, so we'll talk a little bit. You guys probably touched on this throughout the day of the risks of the batteries, hitting thermal runaway and going into fire. But what happens inside the battery? What it causes it? Typically, you get failure of some components, whether it's the separator separating the two halves of the battery, ultimately then resulting in the temperatures inside those batteries increasing, causing then decomposition of the electrolytes, which then result in generation of gases internally inside these battery cells, of which are solvent-based gases, so they're highly flammable, as well as toxic. And that pressure will increase to the point where the battery cell will vent. And depending whether there's an ignition source or enough heat, that at that point of venting is when you could have the fire. We call it a fire. It actually starts almost like a mini explosion. That's when that would occur. And then it would cascade from there into multiple other battery cells that could be adjacent to it. Next slide. All right, so when these situations occur in the real world, the rapid increase of temperature within the space, because of the flammable vapors and solvent based, there's a tremendous amount of heat released. And then as it propagates from one battery cell to the next, it continues to grow and spread very quickly. And because the fire protection means that we have today don't have the capabilities of adequately controlling or extinguishing it, the results are catastrophic. Like the bottom two pictures really are some real world fires that have occurred, where you basically end up having the fire department standing around and just trying to prevent spread of that fire to other adjacent facilities or structures. And the facility involved is a total catastrophic loss. Next slide. All right. So here's just a few examples, right? Lithium ion batteries have been in use for a number of years, but the scale up of them into these large battery systems has really just occurred over the course of the last 5 to 8 years, and seems to be accelerating. And these events are also accelerating in the real world, right? Korea has been an early adopter of this technology. There's been more than 30 fixed energy storage systems, fires in Korea. The Korean government actually shut many of these down and demanded fire safety, systems or loss prevention systems to, avoid potential public harm, right? And you see more and more governments, even NFPA, others, looking at what do we need to do for regulations now? And in the US, the APS fire that occurred a few years back that, caused injury to a number of firefighters, that has really raised a lot of red flags as, this technology, while great and has a lot of benefits, there's a lot of safety risks that, is either unknown or improperly addressed by codes, standards, and general business practices. So this kind of is the tipping point for what, Johnson Controls was looking at. And we say Johnson Controls, you guys probably know us mainly by one of our premier brands, Ansel and Ansel Fire Protection. Really set us down the path of going in and looking at determining what is the root cause, what is the problem here that we need to address, and what's the best way to tackle these issues in the field and in the industry. So this graph you see here really shows the failure cycle of a battery, and this is of like a single battery cell. So that battery cell gets an abuse, so starting right at the 12 o'clock position, and it would progress to the right hand as it continues to get damage and abuse. That cell becomes damaged, weakened, separator materials might fail, the electrolytes begin to degrade, but ultimately it's progressing towards the bottom at 6 o'clock where you hit thermal runaway. And it's not until that point that you actually see visibly externally of the battery that something is going wrong, that you could have smoke or a lot of heat that's being released. But interestingly enough, halfway through what we call the preventative region on that right hand side, there's a phase in which that battery cell vents that gas. There's enough gas to vent, and that's the interesting point of which, if you're able to identify that failure of that battery in that point, by taking some other actions we'll talk about here, you have a high probability of preventing that battery from going into to thermal runaway. So that abuse on the left-hand side in this graph, could occur from many sources, right? You could have mechanical damage like crushing, puncturing. You could have electrical failures from overcharging, actually over discharging, latent manufacturing defects, or an external heat source. Really, those are the abuse conditions that could cause a battery cell to begin to get damaged. And then when you hit thermal runaway, that then goes into a very highly exothermic reaction. There'll be a graph I show later where you can see the temperature and how much it spikes right at thermal runaway. And that heat release then from that battery cell goes into what's called propagation, and multiple battery cells adjacent to the one that fails begins to also then get abused and go into their own breakdown and thermal runaway from there, and causing that large cascading event. So ultimately, once thermal runaway has occurred, from our testing, from many other independent research lab testing, gas suppression systems, water-based systems have very limited impact on extinguishing those fires. Really, you look at what Derek had mentioned with Tesla, the only thing that's really recommended in industry today is copious amounts of water. Surround it, drown it, and keep applying until it goes out, and then even some more after that. Ultimately, what we like to say, I think if you hit the next button again, it'll pop up. The best strategy here really is looking at early intervention, catching it before you hit thermal runaway. Then we have a chance of actually, preventing these fires from occurring. And here's that graph I was talking about. This is actually to the UL prescribed test for bringing a lithium-ion battery to failure. And that the blue line you see here is the heating of the battery, and that we are inducing through a heating element to bring that battery to thermal runaway. So that's why you see that temperature rise. Normally, if it's in a battery cell inside a battery pack, it's very hard to see the temperature of that individual battery cell gradually rising, at least rising out of normal operating temperature limits. But you'll see here, once you hit thermal runaway, that temperature spikes from 200 degrees Celsius to 600 in the matter of a second. And what this graph shows here is once you hit thermal runaway, that's the point when you see smoke, and that's when a normal fire detection and fire suppression system would be able to intervene and take action, which is already too late. So if we look at that point of off-gassing, the off-gas signal, in this battery cell, it was almost 12 minutes prior to actually hitting thermal runaway. So that 12 minutes of time is what we like to say is the golden time, is the time we have to actually take intervene, provide alarm, provide notification, activate systems that can, remove that abuse stimulus, cool batteries, and allow people, personnel, and others to get to safe locations. And this just kind of reiterates that same thing, right? That off-gas point in the preventative region of the battery failure cycle is the point at which our technology that we'll talk about here can actually identify that battery failure. Okay, so this technology, what we call the lithium-ion risk prevention system, was actually developed in conjunction with fixed energy storage systems. And then what the solution that we've worked with Derek and the Levitt team on, we're taking and applying that into an application for really maintenance shops in the mining industry. And they have inside battery racks or inside the system that the Levitt team has brought to market, there's individual cells that can identify and pick up these very specific species of gas. So the solvents used in a lithium-ion battery are pretty unique, and that uniqueness of those materials allow us to have a sensor that's inside these cabinets to be able to identify when a battery has hit that off-gas point at a very, very low concentration level, at a roughly the 1 part per million level, and react within 5 seconds to that. So that signal then goes and is identified and hits into the control system for the lithium-ion risk prevention system. And then that system allows you to communicate into many other systems, like shown here. You could tie that in with a battery management system for a battery to shut down the battery, charging, discharging, or whatever. You could also trigger into, fire releasing panel or a fire suppression system to activate that. So that the key is that early detection, interpreting that detection, and sending an action to another system to mitigate and provide notification. And we still recommend, like that last thing it showed, right? We just always recommend, these off-gas monitoring systems are early advanced for very specific failures of batteries. You still could have external sources of fire that could trigger the thermal runaway or be the source for the thermal runaway. So it's always good practice to have normal fire detection and fire suppression in and around lithium-ion batteries as well. So that graph I showed you before, that was the temperature rise and failure of a battery cell. Here's that same graph, but taking that signal from the off-gas detection, the dark blue line on top, that once we hit that battery off-gas point, we identify the failure, take action. In this case, we remove the heating. And you see the bottom light blue line, the battery cell begins to naturally expel that heat and cool off and avoid hitting thermal runaway. Okay, so then this will just show a couple of the components. Here's that main controller, has capabilities to interface with multiple sensors, both on monitoring sensors, but also reference sensors. So it has the ability to monitor air adjacent and around the system to make sure that there's no false stimuli coming in and causing false alarm. It's gone through some mil-spec and shock testing and things. Here's the individual sensor that's inside these racks in these enclosures. It's very robust, has a 10-year life, has gone through a number of compliance testing here as well. And then these are just a few other of the Ansel and Johnson Controls components that work in conjunction with the off-gas monitoring systems, including our fire detection systems for fixed locations. We also have our vehicle check fire system, that works on the mobile vehicles. And then we have our various different fire suppression systems from, fixed systems to mobile and portables. And what are the benefits of these systems? It provides the earliest possible indication of battery failures. It has the ability to, kind of monitor in conjunction with a battery management system. So if the battery management system has a failure, this system is there to provide, kind of a security net, a blanket, if you will, to monitor and watch the lithium-ion batteries for potential failure. Easy integration into multiple other electronic systems. It allows, to have the identification of the thermal runaway, or failure before thermal runaway, avoiding those, catastrophic failure potentials. All right, back to you, Derek.
Thanks, Derek. It's been fun working with them. We're known as Derek squared in small circles. So where's the solution born? Well, really, one of the reasons I don't present real well is because I'm better in the field and I'm better talking on fire grounds than I am talking in front of a group of people. And so this actually occurred almost 4 or 5 years ago at a mine rescue competition in the Northwest Territories. We put on a fire task. By the way, shout out to mine rescue people in here. I know you're around and really love the support of mine rescue. So actually, Norm Ladekirk, who's in the room here, was sitting on the fire grounds with me as we were doing a fire task, and we started talking about lithium-ion batteries and some of the events that have happened in Canada alone. And we looked at a very small subset of this and just a handheld battery and what can occur from just that. I did this presentation about a month or two ago in Saskatoon with this SMA out there. And at the end of that presentation, one of the guys from it was Easton Crew, said, thank you for addressing this because we had $1.8 million worth of damage occurred to part of their operation due to a simple handheld battery starting fire, propagating itself off, and then off it goes into bigger and bigger and bigger. So Norm here was very gracious. We worked together for a few years as an industry partner, working with us to develop a solution. And we brought in multiple parts of our manufacturing team, so or our manufacturing partners, so JCI being one on the early detection, which addresses that early detection phase. We want to catch it at early phase, hopefully prevent anything from happening. If something even happens from there, next step is to get to how do we contain it. So we partnered with another partner we have in US Chemical Storage. They're a just right company, and that then brings us into a fire locker, which is fire rated, so it can go to 12 or 1100 degrees Fahrenheit, 4 hours, and hold that fire within it. So it can't propagate out from there. Next steps from there are how do we respond? So, or how do we cool? We then add things like a fire suppression system. We can put gaseous or clean agents in. We can use water. We can use foam. Multiple solutions, but really at the end of the day, that's the big question mark that we're trying to fill in. And then from there, Levitt-Safety has a myriad of products that once you do that response, you want to make sure you're wearing the protective equipment, that some of that nasty off-gassing stuff, you're not exposing your workers to at the end of the day either. And on top of that, there's if you do put water to it, you run that risk of hydrochloric acid can be produced when you add water into this because the hydrochlorine gas is produced. So all those things come together. We built a cabinet, we deployed it, we wanted to make sure we have proof of concept. We put it in an underground mine in Nunavut, up at Levitt-Safety mine. It's been there for over 6 months now, so operation's good. What we do to make sure that it's functioning and testing well is we bump test it. What Derek didn't mention maybe was the detection on here is not necessarily, it does not need to be calibrated because you have a reference sensor and a detection sensor. So everything in there, it works off of that. You don't need to calibrate it. It just runs on its own. Bump testing just determines that function test of it. So now we put all those pieces together. And like I said, we've run this through our industry partners in Agawam. Thank you, Norm. Shout out. Oh, and one of my favorite stolen quotes is also from Norm on this topic, and that is, this is definitely one of those cases where technology superseded risk assessment. And now we're trying to all catch up. We're getting there. Here's some pictures of what we did. What I want you to keep in mind, because I know the topic here is BEVs, is everything that we got here is scalable. So we started at very small. We started with handheld batteries. This could fit, could be your AED batteries. It could be e-scooter batteries, whatever smaller batteries can fit into these lockers. But we can take this same technology, including the locker design. It just works into a more of an engineer state, and we can build big rooms the size of this if you want to charge large batteries. So all that came together because we had the right partners. Everything that we did, we made sure we could scale it to effectiveness of BEVs in the workplace because we know it's coming down the pipe. We wanted to make sure everything was very serviceable, that it didn't interfere. We got like these detection sensors that don't require calibration every 6 months. That everything that happens in here is going to happen, and you have the comfort to know that it's going to work. The further innovation side of it comes from when industry's pushing, and I think a question earlier today was, is there innovation on how to suppress fires? I will say that JCI is working diligently. They're probably one of those leaders to not only take this from a suppression endpoint, but to an extinguishment. So as those things happen, we'll work with our partners to put those into play. And early detection and containment. I have to give a lot of thanks to, like I said, our partners in US Chemical and Ansel JCI. They've been very supportive of us. Made a lot of this come to full fruition, and it's been a long process. So I guess at that point, we're just open questions.
So any questions for Derek or Derek Square? Zero. Online,
We
Jenny?
have a few online. I want to ask, what types of off gas do you monitor to detect battery failure?
Derek, you want to go to specifics?
Yeah, I mean, there's a lot of different gases that this will, sensor will respond to that are unique to the lithium ion battery chemistries. But it really is based off the solvents in the batteries. So those solvents that are in the electrolytes is what is triggering it.
Thank you. We have another question here. How does this detector technology handle other battery chemistries such as LFP? I don't know what that stands for. I did ask, but they didn't say. So hopefully someone knows.
Yeah, so the lithium iron phosphate battery. So this sensor actually works with multiple technologies of lithium ion batteries. LFP is one of those technologies. So others would be, NMC, nickel, manganese, cobalt. Those are the two predominant battery technologies that we see in industry. But we've tested it with probably a dozen different variations of those chemistries. And that's what it's been designed to support.
Any questions?
Something here. Now, you showed us a slide that was, I thought, very interesting, where between the time the smoke develops and the fire, 11 minutes interval approximately. So now, I'm looking at it, let's say an operator of a scoop or a truck underground. Now, he sees or smoke or something like that. Now, if we go by this 11-minute time, so what option does he have? Because the fire suppression, you said it needs lots of water, it won't cut it out. So what would be the best strategy there? If you guys could come up with?
So you're saying it's gone past that point of early detection and now it's actually in a fire state.
Yeah, smoke starts.
So a lot of the BEV manufacturers are still using typical fire suppression as a part of that. So, yeah, I mean, at that point in time, you have the activation of your, it could be dry chem. In some cases, they're using NORCAT 1230. So there's some other ways to help extinguish that.
So that's the option he'll have, to trigger the fire suppression system.
And a lot of them are also on an automatic system as well. So they got linear or some kind of automatic detection in there as well. So as soon as that heat or smoke rises, I guess it would be more on the heat side. Then it's deploying that fire suppression system.
Yeah, but there's no guarantee it's gonna put it out, right?
No, so again, we're working on the premise of trying to make sure the operator's safe at this point, get the operator first and foremost out of there. In, most conventional ways of running a piece of equipment, we do put out a lot of fires with our fire suppression systems. I'd say up to 90% or more. But with lithium ion in particular, there's no guarantee of extinguishment. Lots of water, lots of water, lots of water.
Thanks.
Any other questions? Kathy, I want to launch.
Yeah, I have two more. There's a lot of info about detection for stationary storage options. Have any of these detection systems been installed on underground battery electric mobile equipment?
So from a standpoint of vehicle fire suppression being involved with the lithium ion batteries, not yet. There's some technology out there that's coming, and I know that we've been pressing our partners at Ansel who are also working on this part of it as well. Sort of what the issue becomes is in a lot of cases, the batteries themselves are in very contained spaces, and guys like Epiroc and the battery manufacturers don't necessarily want us making penetrations into those spaces. But I think I feel like there's an ability for the folks at like JCI to work with those battery manufacturers to incorporate these technologies.
Great, thank you.
Question?
I had an awkward question, but I think you answered it halfway through, so I'm good. But I just wanted to understand like how it's different from what Andre or Ryan said about BMS system. Because I remember there is an off-gas detection within the battery itself. Correct me if I'm wrong, Andre, like.
So, yeah, we actually just measured temperature. So so our batteries, the chemistry, it likes to operate in the mid 30 degrees. So if you actually start going above that, you're gonna get a code, because there's a thermal management system that wants to keep that temperature in the mid 30s. If you start going into 40, 45, 50 degrees, you're gonna get a warning that, and that's still far away from the thermal trigger. So you're gonna know that there's a problem. It's going outside the regular operating parameter. So even at that point, the operator may be able to stop, and if there's some kind of abuse condition that the BMS wasn't able to stop, then you have maybe even more than the 12 minutes to say you can still do something about that. But for us to detect the fire at cell level, it's temperature wise. That's what we're looking at.
Because you also have the pop tops that if it does start to build up gas.
That's right, you'll vent
You
that
guys don't
gas.
detect it, but it'll vent it
That's
so it
right.
doesn't explode.
And if you've got to the point where you vented gas, you more than likely past that temperature, you've seen a temperature fall as well.
Exactly, that's what I was talking about, the kind of small rupture disk on itself.
Yeah, rupture disk.
Right? So that's why I'm trying to understand business case. I'm sorry, I'm asking a stupid question, I think, but
Not at all.
you know.
I think that this,
Just trying to understand business case for someone to put that investment into this product, right?
and a lot of those engineered advancements really help on the side where it's in operation. A lot of what we're talking about here is trying to help in the case where the batteries are being charged. So it's more on the containment side, even if all of those things put in play, the risk of having all these batteries together compounds that risk. So having, containment, early detection during that stage of charging is really where we're aiming. For now, we'd love to be on the mobile side, we're just not quite there yet.
I'll just call it, sorry. Andre, so let's say, is your BMS system still working? If it is on a ground, it's not on a machine itself, it's a sitting and getting charged and sitting there doing nothing.
When it's
chilling?
charging, it's always monitoring, and currently, when it's not charging, if it's just sitting there turned off, you would have to apply an external source of power, which it's a box you can buy, plug it in and keep the BMS active at all times. We're working on a solution right now in a programming that you could just, it's a long-term storage, you could just turn it on and the BMS will be active on its own with no external. Right now, to have it active around the clock, you need to actually give it a power source and turn it off, which we can also play.
That's
there
where
is a
you
way
can
to have
he can provide that business case. Like when something's not working, the BMS on the equipment itself or vendor itself not working, then we can have the technology. So I'm just trying to understand. Sorry.
Derek, did you have something to add?
Yeah, I was gonna say, I think what we've learned as an industry, as the lithium ion technologies evolve and get used more widely, you really need to have these systems all working together, whether it's battery management system, a fire suppression system, off-gas monitoring system. The best solution is to have these, somewhat redundant systems, and that's what we do in safety and fire protection, right? You got to have multiple layers of redundancy in case one aspect fails, that you have them all working together.
I think Mike mentioned it earlier in his presentation about just a typical fueling station underground. A lot of times we have suppression systems involved there. This would be very much in the same aspect, except taking it to that containment and detection and all of the different sides.
I think the systems that are in place in most batteries now, you're far more likely to have your battery be the victim of a fire than the cause of a fire. So fire suppression systems in a charge bay, in my mind, will be pointed at chargers, will be pointed at infrastructure, at transformers. You don't want a cell fire. The chances of a cell fire starting on its own out of nowhere are pretty slim, but you want to protect those cells from any other hazards that are around.
Any other questions?
We have one online, just the final one. What are the cleanup strategies post-fire? Are there any residual toxic exposure risks at fire sites for workers?
There are, like we talked about, there's lots of VOCs, organic, volatile organic compounds that get produced. And then you mix that with water, and a slurry of sorts of nastiness. So actually there's some products that we carry, the Provor line of products, which are, do you want to speak quickly to Provor?
Sure, the Provor line, actually, if you take the stick that I left on the table, the information is on there. So, you know, to mention that if you add water to a burning lithium battery, you're creating hydrofluoric acid. And so Provor has a product that you can spray on your skin that neutralizes that at home. They also have a product that helps clean up the spill.
So there's a Triverex and Sufferex line, which actually not only encapsulates it, but neutralizes it, brings it to absolute neutral level.
I had a question earlier tonight, I said, but does anybody in the room have any knowledge or roadmap vision of future battery technology? So like, for example, solid state. Like we're talking a lot about conventional lithium ion batteries today, but if R&D is going that route to the point where it can be commercially viable and mass produced on the scale it is today, does anybody have any information on that?
I'm gonna pass this along.
Like Andre, I was going to specifically ask you, like,
Yeah, so
do you have any R&D or roadmap towards that?
So
like through
Northvolt is our battery partner, and I just recently visited the factory at Northvolt, and it's really mind blowing, the things, the research they're doing there and the way they're growing. And yeah, I mean, right now we've got these NMC cells, they're 4,800 cells, so and we expect that to grow. You know, batteries right now, as far as capacity and charge rates, they're growing similar to what the computers were doing a few years ago. I mean, I think the capacity that we have available in the cells now is like 25% more than when we started 5 years ago. So solid state, I'm sure that's coming down the line. Faster charging rates are possible for, you know, right now the C rating of our battery is half C. So we fully expect the next generation of cells to be 1C. So that just allows you more flexibility. If you really wanted to charge your battery in an hour rather than 2 hours, you could, but there's other challenge that brings along with it. When you charge a battery, it's not like if you fuel a truck and you want to put in 100 liters a minute or 200 liters a minute, it doesn't affect the rest of the line. But if I say I want to charge a battery in half an hour, you have to bring a megawatt of power to it. That just doesn't happen by snapping your fingers. But having a faster charge rate, having a solid state battery allows you the safety aspects with no electrolyte. It really brings down the fire risks and analysis and consequences. But the C rating, things like that, those are all improving constantly.
If anybody wants to have a look at, we brought a demo cabinet. So in the front foyer, love to answer any of your questions.
Okay, then you also have the sticks and information on.
Yeah, everybody's got sticks. Help yourself, take them home. Put your instructions for your whatever else on there if you don't want to.
Any other questions? There and there. Thank you. All right, folks, pretty much ends our day. So just a reminder, we have the 2023. So actually it's our 25th mining health and safety conference here in Sudbury, April 8th to 18th to the 20th. So again, lots of information is on our website, so hopefully you'll be able to attend. So I think capacity, we're looking at 300-ish attendees. So it's been a while since we had a face-to-face conference, so hopefully be able to attend. Just like to thank the group, so both the attendees virtually and yourselves here in the room. Hope you got a lot of information out of this. Again, thank you to our sponsor, Levitt-Safety, and our partners NORCAT and Core 5. We want to also thank our speakers and participants for joining us. Hopefully make minds safer. Resource information and a copy of presentation from today will be put on our website and be shared with you within the next few days. All the documentation that's on your tables, please take that with you, print your references as them be. Those traveling, safe travels on your way out. We're supposed to get some snow within. Knock on wood, nothing's coming yet. Right? So any comments before we close it up?
Thank you.
Thank
You're welcome, and thank you.
Thank you.
Okay.